Okay, so this video is comparing the average rate of change to the instantaneous rate of change, or the average velocity versus the instantaneous velocity. So imagine you have a ball that's dropped from a height of 100 feet. Its position at any given point can be represented using the function s of t equals negative 16 t squared plus 100. So that's a ball that's dropped from 100 feet, and s represents its position at any given point, and t is time. So if we want to know the average velocity over some interval, let's say from 1 to 2, we would check and say, okay, where is this ball after 1 second? So this is basically making like an x and y table. In this case, it would be s and t. This would be t being 1 second. After 1 second, 1 squared is 1 times negative 16 is negative 16 plus 100 is, what is that, 84. And after 2 seconds, so in other words, after 1 second, if you drop this ball from 100 feet up in the air, you dropped it. After 1 second, it would be 84 feet above the ground. After 2 seconds, 2 squared is 4. 4 times 16 is negative 64 from 100 is 36. So after 2 seconds, it'd be 36 feet off the ground. So when we talk about the average velocity, it's the change in position over the change in time. It's the same thing as, change in x over change in y over the change in x. Okay, so x in this case being time, and y being the position of the function. So the average velocity would be 36 minus 84 over 2 minus 1, which is negative 48 over 1. And this is feet, and this is seconds. So it's feet per second. So negative 48 feet per second. So that's the velocity. The average velocity equals negative 48 feet per second. And notice that it's negative, and the reason it's negative is because this object is falling. Velocity is worth mentioning if you haven't taken, what am I trying to say? If you haven't taken the science class where you study velocity and acceleration, velocity is gives direction. So negative 48 feet per second. The difference between velocity and speed is just how fast is it moving, but it doesn't give it any direction. So if you ask how fast is this ball falling, after the average speed would be 48 feet per second without the sign. So negative just indicates that it's falling downward. So velocity uses a sign where speed doesn't. That's the only difference between speed and velocity. Okay, so negative 48 feet per second, and this is average velocity over an interval. The instantaneous velocity means what's the velocity, what's the speed of this object, or the velocity at any given moment. So that's the derivative. So if you want to talk about velocity, v of t, what you're talking about here is s prime of t, or the derivative of this function right here. So we learned that the shortcut method is that 2 times negative 16 is negative 32t plus 0, because the derivative of a constant is 0. So this is the velocity function, and you've got that from the position function. And so if you wanted to know v of 1, meaning what's the velocity at 1 second, you would just multiply 32 times 1, and you would get negative 32, and that's feet per second. And if you want to know the velocity at 2 seconds, you plug in 2 and you get negative 64 feet per second. And this is called instantaneous velocity. This is the velocity at that moment. This was the average velocity over an interval. This is the instantaneous velocity at any given moment, how fast. So from the position function tells us where the object is at any given time. From that position function, we're able to find the velocity at any given moment, okay, using the derivative. Okay, so it's worth noting that there's a formula for the position of any free-falling object This is neglecting wind resistance, by the way. This is sort of like in a vacuum. If you were to drop a ball from 100 feet and there was no wind resistance, this would be your velocity. But neglecting any wind resistance, the position of a free-falling object under the influence of gravity is given by this formula. -1/2 g t squared plus VO t plus SO. And in this formula, G stands for gravity. The acceleration, acceleration due to gravity. And it's 32 feet per second. Might cut it off. Oh, I cut off in the video here. Unless you're in metric, and metric would be 9.8 meters per second. Okay, so that's acceleration due to gravity, and that's what would go here. The VO stands for initial velocity. And SO is the initial position. Where did the object begin? Position. Okay, and that's why in the previous example, we had this formula right here. This formula comes from the initial position of the object was 100 feet up when we dropped it. Its initial velocity was 0 because you dropped the object. You didn't throw the object off the roof of a building, you just dropped it. So its initial velocity was 0, so it's 0 times t, which is just 0. And then here we have -1/2, and the acceleration due to gravity is 32 feet per second times t squared. And when you take -1/2 of 32, you get -16 t squared plus 100. So that's where this formula came from that we started with in that example. And so this is what we're going to use all the time. We don't have to use this G. We can just plug in 32 as long as we're not using the metrics. So we would say that S of t, the position of a free-falling object, is -16 t squared plus VOT plus SO. And we're going to use this in different word problems, so it's worth noting. And that's the position of a free-falling object over time, given its initial position and its initial velocity. Okay, so that's instantaneous rate of change versus average rate of change.